In today's lesson, we'll be learning how to apply the slope, midpoint, and length formulas. The focus of this lesson will not be the actual calculations, but the overall strategy. In our first example, we want to find the shortest distance from point P to the line L. The shortest distance between a point and a line happens to be a perpendicular line. Let's work backwards here. Since we want to find the shortest distance between the point and the line, we need to find the length of this perpendicular line. So let's make a flow chart. In order to find the length of a line, you need two things. You need 2 points as well as the length of a line segment equation. As you can see, we only have 1 point. To find the second point, we need to find the point of intersection of the perpendicular line and line L. Again, you'll notice that we do not have the equation of the perpendicular line. And to find the equation of this perpendicular line, we need two things. We need its slope as well as a y-intercept. Again, you'll notice that we do not have the slope of the perpendicular line, but we do know that it is perpendicular to line L, which means their slopes are going to be negative reciprocals. So I'm going to say slope of the perpendicular line and the slope of line L are negative reciprocals. And last but not least, we need to figure out the y-intercept. So to figure out the y-intercept, all you need is the slope of the perpendicular line as well as any point on this line. So I'm going to say the slope of the perpendicular line and point P are needed to find the y-intercept. Now, that is going to be our general strategy for finding the solution to this question. I'm going to arbitrarily call this point of intersection point Q. You can clearly see that the slope of line L is positive 7, which means the slope of line PQ is going to be a negative reciprocal. So negative 1 over 7. The equation of PQ is y equals negative 1 over 7x plus b. To figure out the y-intercept, we need to sub any point on the line. And I'm going to sub point P, which is negative 4, 5. Therefore, instead of writing y, I'm going to put positive 5 in brackets. And instead of writing x, I'm going to put negative 4 in brackets. You can do the calculations on your own, and you should get a b value of 31 over 7. Since we know the slope and y-intercept of this line, we know the equation of the line, and it is going to be negative 1 over 7x plus 31 over 7. Since we now have the equation of line PQ, therefore we can easily figure out this point of intersection, and we're going to use substitution. So I'm going to say sub line L into line PQ. This is going to be pretty easy since they're both in slope-intercept form. Therefore, you're going to get something that looks like this. 7x plus 3 is equal to negative 1 over 7x plus 31 over 7. Now, I'm not going to show you the work here, but if you collect like terms and solve for x, you're going to get x is equal to 1 over 5. And now that you have the value of x, you can sub x back into either of the two equations. So that being line L or line PQ. Let's just say I used line L, which means I'm going to get something that looks like this. So instead of the x, I'm going to replace it with 1 over 5. Again, you can go ahead and simplify that on your own, and you will get a value of y is equal to 22 over 5. Therefore, the point of intersection happens to be 1 over 5 and 22 over 5. Since we were given point P already, and we just figured out point Q, therefore we can find the distance between these 2 points, or the length of this perpendicular line. We can do that by using the distance of a line segment equation. I'm going to use the subscript PQ. Don't forget point Q is 1 over 5 and 22 over 5. At this point, all you need to do is substitute in your known values. So I'm going to use 1 over 5 here and negative 4 over here. And I'm going to use 22 over 5 here and 5 over here. Again, you can do these calculations on your own, and you'll be able to find the shortest distance between P and the line L.